What's up, everybody? Happy Thanksgiving. Hope you guys had a great holiday, great time with your family, great food. But now we must move on. And what's coming up this Saturday is something that's very important. It is the next SAT, and that is going to be given on, what is it? I believe Saturday, December 1st or something along those lines. Let me double check that exact date here. Make sure I'm not getting my things right. Yeah, it's Saturday, November 24th today, so that should be the 1st of December. Okay, so that is coming up. I want to get you guys ready, and as per usual, I'm supposed to do my weekly live streams on Wednesday. Had to go home to Michigan, visit my parents, so the weekly live stream where we're doing SAT math from Khan Academy is happening today. Instead, just got back to LA late last night. So let's jump into it, and we're rocking out systems of linear equation word problems is what we're tackling today. Oh, even more important, a couple other things of business. If you like what you see here today, make sure to click the like button, and please subscribe if you want to see more from Scalar Learning. Just click the subscribe button down below. But most importantly, since we have the SAT coming up next Saturday, we're going to be doing a 5-day cram session this week from Monday through Friday. So make sure to log in and tune in to everything that's going to be going down. It's going to be a bunch of math-related questions, but in response to the many questions I get about the verbal section, the reading section, because I did take the real SAT, and while I don't usually teach the reading section and verbal sections that often, I'm pretty good at them. I got a 750, not a perfect score, but I got a 750 out of 800 last time. So I will be jumping in and sharing some tips on the verbal sections as well. But today we are doing math. And let's do it. Systems of linear equations, word problems. Here we go. As always, I'm seeing these questions for the first time, so that's part of the fun. Never know what exactly you're going to get. And the goal in doing it this way is that you can see me going through the problem solving process in real time. And the other fun thing is, well, we never know what's going to happen. Sometimes mistakes do happen, but they're few and far between, as it should be. So let's jump into it. Ruby can assemble 2 gift baskets in 7 minutes. Emma can assemble 4 gift baskets in 4 minutes. So we got Ruby 2 in 7 minutes. Oops. We have Emma 4 in 15 minutes. Ruby begins assembling gift baskets at 1 p.m. Emma joins her at 1:15 p.m. If both girls work straight through at the above rates, what time will the girls finish the 54 baskets? Okay. Oh, we got 54 total. So let's see how we can think about this here. I know there's a way to set this up. There's like I think there's a format when you have dual rates, and I'm blanking on how exactly to do. There's this is something that I just need to review this formula, but there's a specific formula for this. I'm gonna try and work around solution, but it's something where you set everything equal to 1, and it's these rates like gosh, how does it work? I can't remember. So what I'm gonna do is I'm gonna see if I can figure out a workaround here. So, and also too, the thing is it's not like they're working together. Well, I mean, they're working independently, but sort of at the same time. And we've got some different time options here. So it looks like 2:30 is the earliest that they could potentially finish this by. So if we look at 1 and we look at this other person at like 1:15, right? And this person is really doing, let's say, 16 every hour. So let's think about it like this. We have every 7 minutes. So let's actually, I'm going to go from the standpoint of evaluating these answers here. So if we're saying we have different stopping points at 2:30, 2:42, and let's see, 2:45 and 3. 2:45 and 3. Okay. So in this case, up to 2:30, all right, this person has, and this doesn't even, I actually almost want to get rid of this one because this is 60 minutes, this is 90 minutes, which is not even divisible by 7, which doesn't necessarily mean anything. It still could maybe be the right answer, but I'm just not crazy about that idea as we're going I'm feeling like it should be something divisible by 7. Maybe that's wrong. So 90. This next one is, let's see. This next one is 60. It's 102. And that actually is not divisible by 77 either. Hold on. See if I can find one that is. This is 60 plus 45 is 105. This is divisible by 7. Let's see if my hunch is right. Okay, so and this one would not be. This would be 120. So I'm having a weird feeling that 245 is the right answer, but let's test it out now. So we have 2 every 7 minutes, right? So I'm going to divide this by 7. 105 divided by 7, which is 15, times 2, which means that by 245, what is it? Ruby has created 30 gift baskets. And Emma, okay, by 240, so let's just assume that we're in the same boat here. We're both going to 245. We're talking about 45 minutes plus 60 minutes. No, I'm sorry, 45. So we got 2 45-minute stretches, so an hour and a half or 90 minutes here. And since we can do 4 every 15, that's 24. And that is indeed 54. Okay. So look, that wasn't perhaps the most beautiful algebraic setup that you can put together. I sort of had to think on my feet. Like I said, I think there is actually a formulaic way to approach this problem. But in a pinch, you just got to use logical reasoning. And let's make sure we're right first before I say too much. Okay, we're good to go. So you got to use what's at your disposal, and you can still solve that at a pretty quick rate. But that was my way to get through it, and we got it. All right, next problem. Question number 2. A local grocer wants to mix candied pecans priced at $14 per pound. 14 per pound. And this is, mix canned pecans and candied cashews priced at $10 per pound. All right. How many pounds of candied cashews must he mix? Oh my God, sorry. I'm thinking about question 1. I'm totally now realizing we should have set up 2 linear equations and solved it that way, and that would have been so much easier. But it's okay. That actually wasn't that bad. And now that I think about it, we could have set up a rate problem. But anyways, I'll come back to that. Let's deal with this one. Okay, how many pounds of candied cashews must he mix with 8 pounds of candied pecans to make a mixture that costs $12.50? All right, watch. Here's how we set this up. So it's $14 per pound. So we want a mixture that costs $12.50 per pound, right? So we've got $14 times 8 pounds of candied pecans. 14 times 8, right? Plus $10 times, and that we don't know. How many candied, how many candied pecans? Oh, wait, how many pound of candied cashews? I'm sorry, we're trying to find how many pound of cashews, which is here, right? This is pecans at 14, this is cashews here. Must he mix to make a mixture that costs $12.50 per pound. So it's got to be $12.5 times x plus 8, because this is the total amount of pounds. And this is how, so this should all balance out. We've got $14 per pound of 8 pounds of pecans, an unknown amount of pounds of cashews at $10 per pound, equaling per total $12.50. And then we just isolate and solve for x. This is a calculator problem, but I think we can do it without. 14 times 8 is 80, plus 32 is 112, plus 10x equals 12.5x plus 80, 96. Half of that, oh, it's actually 100. And then we're going to subtract 10x from both sides. And we've got 112 equals 2.5x plus 100. Minus 100, minus 100. 12 equals 2.5x. And then we divide by 2.5. Here we might need a calculator. Let me think. It's 4.8. X equals 4.8. But let's double check. Calculator. So we have, what is it? 12 divided by 2.5, right? Always double check with the calculator on these problems, which are free response, because man, there's no multiple choice to guide you. It's especially tricky, so you have to be very precise with your work. Now let's just make sure this all makes sense. Okay, we have 4.8 pounds. So here that is $48 here. Here we already know that's 880 plus 32 is 112, which equals $160. So $160. And we want $12.50 per pound. So it's, which means in order for this to work, it should be 160 divided by the total weight, which is 4.8 plus 8, which is 12.8. That should equal 12.5. So let's make sure 160 divided by 12.8 equals 12.5. So I feel pretty good. Let's see if it's right. Yeah, all right, we're good to go. Next. These are long problems. A cleaner is sold in low and high concentrations. Let's make sure we don't have any problems coming in here. Any questions? Okay, we're good. A cleaner is sold in low and high concentrations so that customers can combine amounts from each in order to obtain a desired quantity and concentration. Low concentration is 3%, and the high concentration is 18%. This one's probably going to be good to rely on our calculator. How many liters of low and high must be combined to obtain 10 liters? Okay, here's how you approach a problem like this. We have X is the amount of liters of low. Actually, let's call it L and H, sorry. L and H. And we don't know what L and H are, but we know that when added together, they equal 10. Okay, there's equation number 1, pretty straightforward. Now let's talk about equation number 2. We've got 0.03 times my L liters plus 0.18 times H equals 0.08. But it's not just 0.08. That's a mistake that a lot of people make. This is 8% of what? It's 8% of something, and it's 8% of our total, which is actually L plus H, which we already know is 10. Okay. Boom. So this is our equation. But we have two variables in the equation. That's no good. How do we solve or substitute? Well, I can also say that, let's see, I'll say that H equals 10 minus L. Okay? Because again, these guys add up to 10, so 10 minus one of them equals the other. So now let's do a little substitution in here. Make a little more room. Instead of H, we got 10 minus L, and now we're in a beautiful situation where we have a single equation with a single variable. It can be solved, and we can figure this out. So let's solve for L now. So this is, oh, and let's make life easy. Let's multiply everything by 100. So this becomes 3L, right? 100 times 0.03 is 3. That becomes 18 times 10 minus L. Sometimes people say, well, don't we need to multiply this as well? The inside of this? No. We're multiplying this entire quantity. So you could either put the 100 in here and multiply each of those, or as we want to do, which is easier, multiply this outside multiplier equals 8 times 10. Now look how nice and easy this is. This becomes, oops, this becomes plus, distribute that 18, that becomes 180 minus 18L, what am I doing, equals 80. I'll add these guys together, that's negative 15L plus 180 equals 80. Subtract 180 from both sides. Negative 15L equals negative 100. Divided by negative 15, and we get L equals, hold on, 100 divided by 15, Which he goes, ooh, yikes. That doesn't seem good. Hold on. Oh, wait, they do have fractions. Okay. It's got to be this. 6 2/3 liters of low. That's 6 2/3. So that's... Usually that would be a warning sign that we got a decimal like that. But I'm doing that here. Usually on the real SAT, you're not going to have... I mean, I don't think it's going to be as common to have fractional answers like this, but... So the low is 6 2/3, but we want to plug in and make sure that works with both equations. That means high has to be 3 1/3, of course, to add to 10. And if I was being really thorough, I'd plug it in and make sure it works with the second equation. But I'm pretty sure that's good, and if it's wrong, no biggie. And yeah, there it is. But that's what you would do on the real test. Plug it into both equations, because just one equation, you could still have a mistake. Plug it into both, make sure it works for both. But in this nice multiple choice question, you have some more assurances that it's pretty sure you're on the right track. Okay, so check it out. This is not a multiple choice. This is a grid-in problem, which we have to be extra careful. Zaid and Matthias, two farmers, constructed a 792-foot fence around their very large garden. Zaid agreed to construct 20% more of the fence than Matthias did. Okay. So we could say that Zaid, okay, yeah, here's how I'm going to do it. Zaid did 20% more. That's not 0.2 times Matthias, that's 1.2, meaning whatever Matthias did plus 20%. All right, and then it's simple. Now the second equation is Z plus M equals 792. Goodbye Z, and we'll plug in 1.2 M here. And we're gonna have to eventually plug this back in to get Zaid, but that's okay. This becomes 2.2 M, right? Adding these guys equals 792. Divide. It's a calculator problem, thankfully. 792 divided by 2.2 equals 360. So M equals 360. It's nice to use M and Z to make sure that we don't accidentally enter 360 because they're actually asking for Zaid. So Zaid is, we then plug in 360 here, and Z equals 1.2 times 360, which is 72. 432, I think. Of course, I'm going to back this up with my calculator because we don't want any mistakes. Times 1.2 is 432, right? Is that what I said? 432. That feels pretty good. Let's give it a shot. Boom. All right. This one's a long one. At the beginning of the school year, the math club had 3 times as many members as the chess club. Done. Look, systems of equations. These are always going to be on the SAT. It's going to usually always, pretty much always, be 2 equations. So look, I'm halfway done. I got 1 equation just by that simple translation of a sentence to an equation. So start there. That's your starting point. Throughout the school year, 5 members of the math club left and joined the chess club. So M lost 5 and C gained 5. Okay, I don't know what I'm going to do with this just yet. At the end of the year, the math club had 2 times as many members as the chess club. Right. So it means that at the end of the year, at this point, this equals 2 times as much as this. And then we have our second equation. Because this is my end of the year figure, this is my end of the year figure, and double this is this. Be very careful not to put the 3 over here or the 2 over here. We say in math to give to the poor. This is the smaller figure, this gets the 3. This is the smaller amount, this gets the 2. If no one is a member of both clubs, okay, then which of the following systems of equations can be solved to determine? So now this is a question of where we don't actually have to solve for C or M. We just need to match to the correct equation. Now you may be thinking that this is a bit bizarre, right? Why doesn't that one show up? But this is actually the same as this. M minus 3C is the same as if I subtract 3C from both sides and have 0 here. So m minus 3c equals 0 is right. This is wrong. So b and c can be eliminated. Always do this elimination. Then it's either d or a. Now we look at the second equation, and you see what they've done here. It's, look, I'm going to give you a shortcut. Both of these are set equal to 15. One is m plus 2c, one is m minus 2c. Let's isolate the number. So distribute this, it's m minus 5 equals 2c plus 10. I'm going to add 5 to both sides. M equals 2c plus 15. I'm going to subtract 2c, m minus 2c equals 15. And that's A, not D. So if you see a problem like this, you should be happy because you don't have to solve for the variables. It's a bit shorter. And use these elimination tactics so you don't have to check, so it doesn't take as much time to check through the correct and incorrect responses. Let's make sure we're right. Boom, there it is. Okay. Guys, like I said, I hope that was helpful, and I hope that this is helping you get on your way to preparedness for this next Saturday's test on December 1st. And once again, just to reiterate, I will be doing a week-long cram session starting on Monday. We're just going to hit the SAT material super hard and get you guys in great shape. We are even going to spend one day doing verbal reasoning and it's essentially the reading and writing sections from the October SAT that I took, for as so many people have requested. So I'm finally going to oblige that request. But make sure to jump on here on those live streams. I'm going to post the times each day, one day in advance of when we're going to be doing those live streams. Come on, ask me questions, and let's get you guys ready. So it says, when will you do the SAT revision? I'm not sure what the SAT revision is. Do you receive the link for the SAT? Yeah, I did for the October test. And I'm sorry, was it, did I take it in October now? I'm trying to remember. Yeah, I think I took it in October. So I did receive that, and I went through it. You should check out, when I was prepping people for the November SAT, I went through the entire October SAT, so check that out. And yeah, so Damien, I'm not sure exactly what you mean by the SAT revision. But guys, like I said, I hope this was helpful. Please click the like button right now if you did find this helpful. And if you want to see more of this, make sure to click that subscribe button, and you guys will stay abreast of everything that's coming to you from Scalar Learning to get you ready for the standardized tests and the math sections in particular. Thank you guys so much for joining, and I'll see you all next time. Take it easy.